All right, welcome back, everyone. Hopefully you all did well on your second test. Today we're going to talk about characteristics of functions, in particular what they look like. So in this section, you're going to learn how to determine when a function is increasing, decreasing, or constant, how to write these intervals in interval notation, and then how to determine the relative maximums and minimums of a graph. We say that a function is increasing if its y value increases as x increases. So when you look at the graph, the function's rising from left to right. So you can see a picture of this here. As x increases, the y value increases. And this means that the function is increasing. We said a function's decreasing if the y value decreases as x increases. Right? So as x goes up, y goes down. When you're looking at the graph, a decreasing function falls from left to right. It's going to be going down from left to right. And finally, a constant function is said to be a constant function that the y value doesn't change as x increases. So as x gets bigger, y doesn't change. Y stays the same. When looking at a constant function, there's no change from left to right. Right? What you get is a horizontal line. And so all functions can be increasing, decreasing, or constant at some points, right? Or along some intervals, and that's what we're interested in. We want to be able to determine the intervals where the function is increasing, decreasing, or constant. To do that, we just want to find the starting and stopping points. Right? Where does the function start increasing, and where does the function stop increasing, or decreasing, or constant? And we're always going to be dealing with x values. So whenever we write the intervals for increasing, decreasing, and constant, we're always going to use parentheses. We will never include the endpoints of these intervals. The endpoints can be called something else, which we'll talk about in just a few minutes. By definition, there must be a point before it for the starting point to be increasing. Okay, so endpoints are not considered increasing, decreasing, or constant. So we always use parentheses when we're writing these intervals. So here's an example. We want to determine the intervals where the function is increasing, decreasing, or constant. And so we're going to look at this picture from left to right. And we want to determine where is this function increasing. If we look at it from left to right, where is the function going up from left to right? Where's the y value increasing from left to right? When we see, we can start at 3, or x equals 3, and go to x equals 5, and along that interval, the function is going up as x goes up. So this graph is increasing along the interval from 3 to 5. Pay attention that this is not a point. These are x values. This is from x equals 3 to x equals 5. This is interval notation. So now we want to determine where is it decreasing. Well, the graph is decreasing if it's going down from left to right. And so for what x values is this function decreasing? Well, we start looking at the function from all the way to the left until we get to x equals -1. That part of the function is going down. So from minus infinity to -1, the function's decreasing. But that's not the only point where the function's decreasing. Beyond x equals 5, the function is also decreasing. So negative infinity to -1, and then positive 5 to positive infinity. Those are our two intervals where the function is decreasing. Notice these are separated by a comma. Finally, we want to determine where the function is constant. Where is the y value not changing as x increases? And we can see that on this bottom piece here, from x equals -1 until x equals 3, the function is constant. And so the interval where it's constant is -1 to 3. Let's try another example. We just want to determine where this function is increasing, decreasing, or constant. And so let's start with increasing. And so we're just looking for the intervals where the function is going up from left to right. And so we can see that if we start here and go up, our x value is from -3 to -1, so it's increasing from -3 to -1. But also if we look over here to the right, the function is also increasing from +3 to x equals +5. To determine decreasing, we're just looking for where it goes down from left to right. And we can see that it goes down from left to right from x equals 1 to x equals 3. So from 1 to 3. And finally, we want to determine where the function's constant. And we can see that it's constant from x equals -5 to x equals 3. Or to -3. Notice that in the past two examples, we've accounted for the entire function. The function is either increasing, decreasing, or constant. And it will account for the entire function on both of these. So in between intervals where we have increasing and decreasing, we can have things that are called maximums and minimums. When a graph changes from increasing to decreasing, this point's called a relative maximum. You can see this here in the graph. The function is increasing, and then it stops and turns around and starts decreasing. The point where it turns around, the point where it stops increasing and starts decreasing, is called a relative maximum, or a local maximum. A relative maximum, because relative to the other x values around it, it has the greatest y value. This does not need to be the highest point on the graph. It just needs to be the highest point relative to the points nearby. Similarly, when a graph changes from decreasing to increasing, we get what's called a relative minimum. So if it's going from decreasing to increasing, here we get what's called a relative minimum. Relative to the points around it, relative to the x values in its neighborhood, it has the smallest y value, or the least y value. Once again, it does not need to be the lowest point on the graph. That can be seen here. We also have another relative minimum at a later point in the graph. But it's greater than the first relative minimum, but they are both relative minimums. Relative to the points nearby, they both have the least y value. So when you're dealing with functions that go from increasing to constant or decreasing to constant, that transition doesn't really have a name. These points are no greater or lesser than all of the points around them. So for example, we saw in this example earlier that we went from decreasing in the first part to constant at this point here. Notice that relative to the points around it, it does not have the least y value. All the points to the right have the same y value. However, if we look at x equals 5, at this point the function is going from increasing to decreasing, and so we get a relative maximum. And the relative maximum is 2 at x equals 5. So when we refer to the maximum or minimum value, we're asking for what's the y value at the point where the maximum or minimum occurs. So let's try this example. For this given graph, we want to determine the intervals where the function's increasing, decreasing, or constant. We're going to determine whether it has a relative maximum or minimum, and then we're going to determine the max or min of the function. Well, if we look at this function, it's going up from left to right, starting from, it's increasing from negative infinity all the way to x equals 2.5. It's then decreasing from x equals 2.5 to positive infinity. There is no point where this function is constant. It's either increasing or decreasing. And so if we want to determine it as a maximum or a minimum, we just have to look at the function. The function goes from increasing to decreasing, and when you go from increasing to decreasing, you get a relative maximum. Notice that point is higher than all the other points around it. And so it has a maximum, and the maximum value is 3.25 at x equals 2.5. Let's try another example. We want to determine the relative maximum and minimum of the function. Well, we can kind of look at the function and determine this, or we can use the intervals. We can see from the graph that the function is increasing from 0, or 0.103, to x equals 3.601, and it's decreasing everywhere else. And so at the first point, the function is changing from decreasing to increasing, and we get a minimum. And that minimum is 0.995 at x equals 0.103. And as we go along a little further, we see that the graph goes from increasing then to decreasing, and we get a maximum of 2.921 at x equals 3.601. So at the end of this lesson, you should be able to determine the intervals where a function is increasing, decreasing, or constant. And you should be able to find the relative maximums and minimums of a graph.